So for our new essential skill, it's going to be coordinate geometry. The big major concept really of this is being able to classify some shapes. So on the very first page of your notes, the basic shapes sheet, make sure that you have all of the markers that go in with that. And we can talk about that too if you would like. But the big focus that we've done so far is calculating the length of things. So the length of a line segment. And that's really one of the things we're looking at here. So we've got distance, but calculating distance is the same thing for us as finding the length of a segment. Now, I'll be honest with you. I gave you this distance formula here that I just circled in green, but we're not using it at all. So I'm going to completely ignore that because I'm a big fan, as you guys know, of using something that we already know. So we're going to use the Pythagorean theorem here. So visually, you really might want to have a picture, which is really kind of what we've been doing recently. So we're going to calculate the lengths of things. Now, if the length or the line segment is horizontal, so I'm going to put it off to the left-hand side here, and I'll color code it in blue. So if I have a line segment that is horizontal, and I can just count the boxes, that's exactly what I'm going to do. So just count the boxes. Or if I have a vertical line segment, so straight up and down, I'm going to do the same thing. I'm just going to count the boxes. So if it's vertical, just count the boxes. If there is a tilt, though, to the graph, so I'm going to go over to my Pythagorean theorem here. I'm going to say this in green. I am going to use a squared plus b squared equals c squared if my line segment is tilted. Okay, so let's take a look at our first picture, and I'm just going to go in order. So my first line segment is AB. All right, so let's do some color coding here. So line segment AB. If you take a look at the picture, line segment AB is straight up and down. Since it's straight up and down, so color coded in red, I can just count the boxes. So it looks like I've got 1, 2, 3 boxes. So this length here is 3, which means the length of AB is 3 units. We don't know if it's going to be feet, inches, miles, kilometers. Doesn't really matter. Okay, let's do the next one in orange. So we're going to go A to B is already taken care of. So that's my first one. So let's do B to C now. Okay, B to C, if I take a look at the line segment, that is a flat line. So that's horizontal, which means I can just count the boxes. So it looks like I've got 1, 2, 3, 4 boxes here. So that means that the length of BC is just going to be 4. Okay, moving on. Let's do some more color coding here. Let's use green. I'm going to go C to D. Well, you'll see that C to D is tilted, which means I need to use stuff that I already know. So let's do Pythagorean theorem. So here's what I'm going to do. I'm going to make that CD line segment the hypotenuse of a triangle. So I'm going to draw a right triangle using the boxes around the outside. The little box there. I see that the base of that CD triangle is 2 boxes. I'm just counting the boxes at this point. And then the height is going to be 1, 2, 3, 4, 5 boxes. So I'm going to take that green triangle over here to be able to do CD. So on CD, I'm going to have this green triangle that we just did. I know that it's got 2 across the bottom, and I know up the side is going to be 5. Now, if you think back to what we just did with the triangles ESA, I'm going to put an X there for my hypotenuse. I can do Pythagorean theorem here. So let's do leg squared, 2 squared, plus leg squared, 5 squared, is equal to x squared. Remember, grab your calculator on this one. So we're going to do 2 squared plus 5 squared. If we type that in, and hopefully you're writing with me as we go, I think that gives us 29. But we still have to get rid of the squared. So let's square root both sides. So square and square root cancel. And if we take the square root of 29, I got 5.38 5. So I know that this is CD. So CD is approximately 5.385 units long. Now, we need to keep going. We have to figure out what DC is going to be. So we want to loop the entire thing, or excuse me, DA. But if you take a look, DA is tilted again. So I'm going to draw another triangle, and I'm going to use Pythagorean theorem to help myself out here. Okay, it looks like this is 2 boxes tall, and then 1, 2, 3, 4, 5, 6 boxes long. Okay, so for DA, so just finishing my loop all the way around, I now have this rectangle. That's got 2 and 6. Now, I'm not going to call the hypotenuse x this time because I already used x, so I think I'm just going to use y. So Pythagorean theorem, leg squared plus leg squared is equal to hypotenuse squared. Okay, if we type this in, I think this gives us 40 equals y squared. Square root, with the square and the square root cancel. When we square root 40, looks like we get 6.324 or 6.325. So what I was able to do was figure out how long all the side lengths are. One of the things that we do with all of the side lengths is we calculate perimeter. So just as a reminder over here in the margin, perimeter, that's when you add up all the side lengths around a shape. So we add up all side lengths around the shape. And honestly, our focus hasn't really been perimeter. It's just been calculating the lengths. But since we're here, we'll go ahead and do P equals, so perimeter. Well, AB was 3 plus BC is 4 plus CD was 5.385 plus, finishing the loop, D was 6.324. So perimeter is going to be all of those guys added together. So 3 plus 4 plus 5.385 plus 6.324. And that gives us 18.709. So that was our first day, was really going through and doing distance. So all we practiced was either counting the boxes, if it was straight up and down or straight right and left, or we created right triangles and used Pythagorean theorem. Okay. Second day. Second day, we used the idea of slope. And this goes back to stuff that we did, oh man, a couple essential skills ago. Yeah, a couple essential skills ago. I think we focused on it not on triangles, but the one before that. I don't recall. But, transformations. So we want to use our slope formula. But the reason why the big focus is this whole parallel and perpendicular business. So, and I'll be honest with you, I did the same thing here with this formula. I just kind of ignored it. And I looked at this one, since this is the one that we use the most. Important thing to note, though. So parallel, let's see, the symbol for parallel. And then we also have the little floating arrow tips, if you guys recall that too, on like a line segment. Perpendicular, we know, is the upside down capital T, but in the picture, it looks like an actual box in the corner. If you guys recall, parallel means the slopes are exactly the same. They're identical. For perpendicular, you have that opposite reciprocal. So you got to flip the number over and you need to flip the sign. So if the fraction's negative, to be perpendicular, the other slope has to be positive. Has to be. The only two oddballs are the 0 and the undefined slope. All right, so let's go through, and we're going to go through and find the slopes of these guys. So I'm going to try to use my color coding from before. Okay, I did red for AB. So I'm going to talk about the slope from A to B. And it's totally up to you if you want to start at B and go to A or start at A and go to B. Remember, we use M for slope, and I'm going to go from A to B. Okay, so remember the top of slope is rise. So if I'm up at A, it looks like I have to go down 3 units. So down 3. But once you go down, you're already at B, so there's no run. You have to remember this, though. We're not allowed to divide by 0. Whenever you have 0 in the bottom of a fraction, we know this is undefined. So my slope for AB is undefined. Okay, next one. I think I used orange, so let's stick with that. So we want to go from B to C. So B to C. Okay, I'm going to do the same thing. So the slope from B to C. All right, from B, there's no rise. There's no up or down. So rise is 0. Run looks like it's 1, 2, 3, 4 to the right, positive 4. If you have 0 on top of a fraction, this is 0. Okay, let's keep going. Next color, I think I used green. Now C to D, it's got that tilt, but we know how to do slope. So if we're at C, it looks like I'm going to go up. Let's see how many that is. 1, 2, 3, 4, 5. Okay, so that's up 5. And then I'm going to go right 2. So slope from C to D is up 5, positive 5, right 2. And I would type that in the calculator and see if I can actually simplify it, but I can't. It's just 5 over 2. All right, and then our last one, we want to finish the loop here, which I did in purple. I'm going to find the slope from D to A. All right, it looks like I'm at D and I'm going to A. So I have to go down 2, down 2, and then left 6. Type this in my calculator, turn it back into a fraction. This gives me a positive 1/3. Okay, so we went through, we calculated a whole bunch of slopes. Now we want to pull together the stuff that we did the previous class and this class. So since I'm on this screen, I'm going to stay here for a second. I'm going to ask myself if any of these slopes are exactly the same. If they are exactly the same, that means those 2 line segments are parallel. But if you take a look at these slopes, I've got an undefined, a 0, a 5/2, and a 1/3. None of those are the same. So no sides are parallel. So no sides are parallel. Okay. Perpendicular. Yeah, actually, we do have perpendicular. We've got the oddballs here. So often margin here as a reminder, undefined slope and 0 slope, those are perpendicular lines. Perpendicular line segments. So that means that line AB is perpendicular to line BC. As a reminder, perpendicular means it's 90 degrees. So let's go to the picture. We're going to put a box where AB and BC hit each other. So that's 90 degrees. Okay. So I used my slopes to determine if any of them were parallel and then if any of them were perpendicular. Now I'm going to go back to the lengths. I'm going to see if anybody's the same length. So back to the previous screen. All right, if I look here, I had a 3, a 4, a 5 and some change, and a 6 and some change. None of those are the same length. So since none of them are the same length, then I would say that no sides are congruent. So I'll go back here. Actually, may as well do it here because we're talking about length. So no sides are congruent. All right, so here's what we know. We know that no sides are congruent. We know it's a four-sided shape, four sides. We know that there is a box in the corner. So if I go back to my basic shapes sheet, I will start eliminating. So now this is a quadrilateral because it's got four sides. But it's not a kite, doesn't satisfy the requirements. Take a look at the tick marks on that kite. It's definitely not a rectangle or a square, has no chance. Can't be a parallelogram or a rhombus. I think we're just stuck with a quadrilateral. That's the best this thing is. So if I want to classify this, I would say that A, B, C, D is a quadrilateral. That's it. It doesn't have a special name because it doesn't have any of the characteristics that would make it special. So thinking about like a parallelogram, you have to have parallel sides. You have to have opposite sides are congruent. It's a whole bunch of stuff with a parallelogram. So hopefully this helps a little bit with what we've been doing. If you still have questions after you've watched the video and tried the second part of the example, so take a look at 721 page 1. There was another four-sided shape. And then 721 page 2, it's the same four-sided shape as the second question on that one. If you have any more questions after taking a look at that and watching this video, let me know.